Hello, Hornets. Thank you for joining me today. Today I'm taking a look at some solving problems that involve us using the dummy variable. Now, the dummy variable is something that some people are struggling with, so I wanted to make sure that we took a look at a few so that you would have the opportunity to see the patterns. Now, what you're always trying to do is recognize this e to the 2x. See that e to the 2x right here? This is really e times x, or e to the power of x, the quantity squared. Then you have a 21 e to the x. Now this is always the way it's going to be when we're looking for them. So I need you to look and break out that 2 so that you can then look at your middle term and say u is equal to e to the x. Now we can do a substitution. U squared plus 21u minus 90 equals 0. And from that we can factor out 3 u squared plus 7u minus 30 equals 0. From here I can now factor it. And I'm trying to do two numbers that are separated by 7. So let's see, we've got 6 times 5. We have 3 times 15. We have, let's see, well, that's not 3 times 15, that's 2 times 15, Mr. Lamb. And we have 3 times 10. So 3 times 10 is going to be my solution. So I have plus 10 minus 3 equals 0. This lets me have u equaling negative 10 and u equaling a positive 3. Putting in e to the x equals negative 10 and e to the x equals a 3, you'll notice I'm trying to get a negative number out of a positive piece. That's never going to happen. E to the x is always greater than 0, which means that this cannot be a solution. I then exponentiate e to the x equals 3, natural log of 3, excuse me. X moves in front, natural log of e is 1, and x happens to equal the natural log of 3. There's my solution. Let's try another one. Let's take e to the 2x minus 9e to the x plus 20 equals 0. Start by looking at it as e to the x, the quantity squared, minus 9 parenthesis e to the x plus 20. Let u equal e to the x so that I can then do u squared minus 9u plus 20. I'm going to factor it into u and u, two numbers that multiply to give you 20 and add to give you negative 9 are a minus 4 and a minus 5. That means that u is equal to 4 or u is equal to 5. And by back substituting e to the x, we get e to the x equals 4 or e to the x is equal to 5. Exponentiating, I get natural log of 4, natural log of 5. X moves in front, and the natural log of e is really 1. And I end up with x equaling the natural log of 4 and x equaling the natural log of 5. And these are my solutions. Let's take another one. This time, let's take e to the 4x plus 2e to the 2x minus 24 equals 0. Now this one's going to be a little bit more tricky, so we have to be careful. We're going to start by looking at it as e to the x, the quantity to the 4th, plus 2 e to the x, the quantity squared, minus 24 equals 0. This gives me u equaling e to the x, and I have u to the 4th plus 2u to the 2nd minus 24. I'm going to now factor it into u squared, and I'm going to have a 4 and a 6. where the 4 is going to be a minus and the 6 is a plus. This is going to give me u plus 2, u minus 2, u squared plus 6 equals 0. Now, this u squared plus 6 is prime, and there is no 0 that is a real value that will work. So we have only u equaling negative 2 and u equaling positive 2. Since this is e to the x equaling negative 2, we can get rid of it, leaving us with only e to the x equaling 2. Exponentiating, x has to equal the natural log of 2, and that is my solution. Let's try another one. This time, let's take a look at 21e to the cube of x minus 24e to the square x plus 35e to the x minus 40 equaling 0. So I'm going to start off by letting 21 e to the x, the quantity cubed, 24 e to the x, the quantity squared, 35 e to the x minus 40 equals 0. Let u equal e to the x so that I have 21 u cubed minus 24 u squared plus 35 u minus 40 equaling 0. I'm now going to attempt to factor as best I can. So I'm going to take out a u squared, and I'm also going to take out, let's take out a 3. That's going to leave me with 7u, and I'm taking out an 8. Plus, factor out a 5, leaves me with a 7u minus 8 here. And I now have 3u squared plus 5 times 7u minus 8 equals 0. This is a prime term and therefore will not have a solution, but u will equal 8/7 here, allowing me to go e to the x equals 8/7, and when I exponentiate, x has to equal the natural log of 8/7. This is my solution. Let's do one more and then we'll stop. This time, let's look at 4e to the 3x plus 14e to the 2x minus 6e to the x minus 21 equals 0. Start by breaking off the cube so that it is 4 parenthesis e to the x, the quantity cubed, plus 14 parenthesis e to the x, the quantity squared, minus 6 e to the x, the quantity, minus 21 equaling 0. Let u equal e to the x so that you get a more simplistic equation. 4u cubed plus 14u squared minus 6u minus 21 equals 0. Factor out. We're going to take a u squared and I'm going to take out a 2. It's going to leave me with a 2u plus 7, and I'm now going to take out a minus 3. This leaves me with a 2u plus 7. I end up with 2u squared minus 3, the quantity times 2u plus 7, equaling 0. This then factors into the square root of 2u minus root 3, the square root of 2u plus root 3, and 2u plus 7. I then get u equals the square root of 3 halves, u equaling the negative square root of 3 halves, u equaling negative 7 halves. But this is still e to the u, so e to the x, and I'm looking at 3 halves to the 1/2 power. I have e to the x equaling a negative number, which is not possible in either case. So I'm only working with this one where I exponentiate. I know I have my natural log, so this is x 1/2 the natural log of 3/2. And this is my solution. So this was an attempt to try to help you to practice finding solutions when you have polynomials that have extraneous parts like e to the x or logarithms or log base 2 or something that we need to use a dummy variable for. I hope this has helped. If it has, please click like, and if you have suggestions, please feel free to give them. Thank you very much, Hornets. I hope this has helped. Bye-bye now. Cheers.